So randomness is a bit of a tricky subject. Mainly because we can get into a huge philosophical argument about determinism and whether anything is actually truly random or not. For instance, if you were to roll a six-sided die, one could argue that you could predict the outcome of the roll if you knew all the initial conditions, such as the force at which you threw it, the angle at which you threw it, the height at which you're going to be rolling it at, the how it's going to be able to bounce off the surface that's landing on, so what kind of surface it's landing on, pressure, air resistance, right? Any kind of spin if you know all those, those initial conditions, you could throw that into a physics equation and predict the result. But the thing is that what we care about is that if we roll that dice, or that die, if we know all that, we could predict it. One could argue that the result is deterministic. But the idea here is that the output will be statistically random. And so that's what your computer's going to do. It's going to use some information here. It can't really it's working with bits, right? It's working with electricity here. There's not really much in the way of randomness that it can do, because randomness in electronics sounds like a great recipe for explosions. So it's going to try to produce statistically random numbers, what are called pseudo-random numbers. Now, almost every programming language has the ability to use random numbers, and they're typically in a library called random. Here, that's the case in Python, and to generate a random number, there's basically two ways we'll do so in this class. The first way is to say, hey, my result is equal to random dot, not roll, but rand int, which will give you a random integer. And notice it says over here, return random integer in range A to B. Notice the brackets. It's using mathematical inclusive notation there, right? Where brackets for include, parentheses for exclude. So it says including both endpoints, so A to B. Now the reason it mentions that is because most everything else in Python is inclusive on A, but exclusive on B. So, in other words, it includes the first part, but not the second part. It cuts off that's when it will cut off at. But here, if I were to say 1 to 6, this would simulate us rolling a six-sided die. And I can't really do anything fancy here because we don't know about if statements or for loops yet. But what I can do is I can run this a bunch of times. And we can see that we've got these results coming in here. And it looks fairly random, although we haven't gotten a 1 yet. That's okay, because this is just a fairly short sequence. So it's not going to be even. See, there's our 1. Also, note that basically 1 was no more likely to appear there than anywhere else, because it's random. These are independent events. Now, one of the things that we will do in this class is give you a nice taste to introduction in statistics through the birth of statistics, in my opinion, which is gambling and scams. Which is namely, we are going to simulate games like blackjack, and we're going to simulate things like some games that scam artists use to show you basically what the odds are of things are. And we do so with something called a Monte Carlo method, which sounds really complicated, but it's really not. It just simply is a way of saying that math is hard, I don't like math, but we know the rules of the game, so let's just have the computer play like a billion of those games and tell me what the outcomes are. Because if I play it a billion times, I'll probably have accurate results for what the outcome is. And so, rather than trying to calculate it, you just simply you run enough games such that the significant figures in error don't really matter anymore. So we'll have a lot of fun with randomness here. So this is one of the ways we're going to use randomness. The other way we can do something is that we can use the random function, which will, we can see what it says over here, returns x some number in the interval from 0 up to but not including 1. Now for you mathematicians, so mathematically, how many numbers are between 0 and 1? Right? Not how many integers, how many numbers are between 0 and 1. If you went with infinity or some variation thereof, go and get yourself a cookie or something. That's correct. There are an infinite number of numbers in mathematics. In computer science, we are limited by the number of bits. But, silly me, talking and coding at the same time. So we do have limitations. But here, this generates a random number between 0 and 1. And if you're wondering why that's useful, you can have some kind of you can figure out some kind of threshold. So, hey, if it's below 50, if it's below half, then it's one outcome. If it's above half, it's another outcome. So this is another way, but most of the time we're going to be using rand int to generate our random numbers. So I've shown you math, I've shown you turtles, and showed you random. Those are basically the three ones that we will be using in the future. Oh yeah, and while your book doesn't necessarily use it, I will be using this quite a bit, which is that there's a function here called random.shuffle, which will, given a list of things, will shuffle around. So let's go ahead and actually show that over here. So can I use it on a string? Let's see if I can use it on a string. 1, 2, 3, 4, 5, 6, 7, 8, 9. Can I use it on a string? Nope, I cannot. I cannot use it on a string. It has to be a list. So just bear with me. It's a list. It's not too scary. The idea here... Actually, you know what? I won't scare you. I'm just going to say turn this into a list. Right? Remember, if there's a function for turning stuff into strings, and lists are a thing in Python, we can totally do that. None. Oh, right. All right. See, I make mistakes too. I forget how things work, and I try to be clever. So let's go ahead and just basically say my nums are equal to the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9. What is a list? It's basically a variable that holds multiple... It's basically a variable or a literal, depending on your case, that holds multiple things in it. And it cares about the order of them. Right? There's our numbers 1 through 9. Now if I say rand.shuffle them, I'd say shuffle the things around in there and give me the result. All right, we want to print out nums. See, these are actually all unintentional errors on my part. I make mistakes, I make mistakes programming too. Nums. Should not try to talk and code at the same time. All right, 974. So here we go. Right. So this is fairly straightforward. Right, again, we don't cover lists until much later, but I wanted to show off this function and how it can kind of be useful. Right, imagine instead of some numbers, you have a deck of cards. So it's a very useful function.